classwork and respond. 100% I am telling here, no need to prepare again. No need to prepare again for your examination. Here, if you are attending my classwork, revision classwork from first onwards 15 days, here I think we get 8 hours. In that 8 hours, we must discuss more and more things. And if you are really participating with preparation in my classes from 1st to 15th for this revision, here you will get more than 90 and no need to prepare again at the time of examination. Here your preparation will done. So that we have to plan accordingly, so that you please support and come with preparation for attending of my class. So this is the job, you do it. I will tell you before that first unit revision, then you need to prepare first unit. So that we can learn, all of you combined will learn and we can get the full mark. So this is my idea. Okay, accepted everyone?
Yes,
Everyone
sir.
is accepted this proposal.
Yes, sir.
Yes, sir.
Yeah. So my intention is everyone must get above 90. So this is what we have time now, 15 days time. Then we can do the wonders. Okay, right. So coming to today's experiment. Today's experiment is, I think, which experiment? Seventh experiment. Correct? Hello? All of you, I think, completed this bubble sort, selection sort, insertion sort, execution. Correct?
Yes, sir.
Yes, sir.
Hello? Yeah. Now today's experiment is seventh. The seventh experiment is write. Yeah, the seventh experiment is write a program that use both recursive and non-recursive functions to perform the following searching operations for a key value in a given list of integers. The first one is linear search. The second one is binary search. Sure, I think you people already aware this linear search and binary search in your first year. Yes or no?
Yes,
Hello?
sir.
Yes, sir.
Yes, sir.
Now tell me anyone, what is a linear search? What is a linear search? Hello. Any one of you please tell what is a linear search? Please unmute your mic and tell me. Because this is not right way. That is what I told you. You must speak something. Already you people are working on this linear search and binary search in your first year. Don't waste the time.
So we start from the leftmost element and compare all the elements till the element is found.
Sorry.
A unidirectional searching technique.
Yeah, I am not asking the definition. I am asking procedure of linear search. How to search element with help of linear search. Yeah, tell me. Hello.
So
Each
it is a
element
searching
will
technique
be
wherein
No information. This is not right way. I'm asking a very simple question.
There will be a key element. That element will be checked from the first till the last element.
Yeah. Now, uh, yeah. What is binary search? Hello.
the list will be divided into two parts. Uh, the lower
Okay.
index value and the higher index value will be divided by two. We'll get a midpoint. We will
Mm.
check the search element whether it will be under to the left side of the midpoint or to the right side of the midpoint. If it is to the left
Whether
side,
that
we will
search
get it
element
big,
is greater than the mid element or
Mm. Yeah. Right.
and then if it is less
Continue.
than the midpoint value, then again we will uh, add the index values of that starting index value to the again mid element index value and then divide by two. We get again a midpoint. If the element is still less than that midpoint, we'll move to the left side. If it's greater than that midpoint value, we'll move to the right side. In that way, the search continues until we find the element or the uh, list ends or is there no value.
Yeah. Right. Good. Good. Yeah. Now the thing very simple. Whatever they explained, right? They are coming to the linear search. Linear search. Here, this linear search mechanism is a simple mechanism. Generally, human being will do same procedure. Here, the searching must be done in a linear fashion. Means here, if we are going to store elements in array in a random order, now you know how to write the program. Use for loop and you will initialize the array and store the elements. Whatever the elements you want. Like that you can store. So this is the size of the array you declare. Based on the size, you can add the elements. So now you want to search the elements in a linear fashion. So you need to search one element. You need to store in a key that element. I want to find three. Now linear means sequential. Here one by one means you need to maybe if it is array. Now this is a zero indexing. 1, 2, 3, 4, 5. Means the array size is n equal to you know how much? N equal to 6. You know, the size is n minus 1 only. Okay, now I want to search 3. Now to search, now key equal to array of 0. Array of I. ARR of I. So that I is incrementing here like this. Here we have to compare. Once it is going to match somewhere, you will tell if the element is found in the particular position. Otherwise, the element is not found. Yes or no? Hello?
Yes, sir.
Hello? Yeah. Yeah, this is what exactly the linear search. Now coming to the binary search. So binary search is nothing but we are going to divide the given elements into two parts. But when you are reading elements, those elements must be in a ascending order. You must be enter elements in a ascending order. Are you following? Or descending order. Any one of the order you need to follow. Means the elements, whatever the elements you are entering into the array, the time of reading, those elements must be in a sorted order. Are you clear? Hello? Hello? Are you clear this?
Yes, sir.
Yes, sir.
Here I am taking ascending order. You can take descending order also, not a problem. But the elements must be in a particular order you need to enter. So that is what exactly the first step. So comparatively with linear search, binary search, linear search you can take elements in any order, random order, not a problem. Then you need to check one by one. But when it comes to the binary search, the elements must be in a sorted order. Maybe the ascending, maybe the descending. That is very, very important. And once you are going to search a key, now I want to search a key equal to 3, I want to search. 3 is available or not, I want to search. If you want to search a key, then we first, after reading this element, now you want to search a key, then you need to divide a list into two halves. Yes or no? Hello? Means we need to find the mid element. How to find the middle element? 0 plus 7 by 2. Tell me how much? You need integer value. Hello? Binary means two parts. This is the meaning, the name, binary. 0 plus 7 by 2. How much?
Yes, sir.
Response is required quickly. Hello? Hello?
Please, sir.
0 plus
3.5, sir.
yeah, means 3 only. Correct? If you take integer, that is a 3 only, right?
Yes, sir.
Yes, sir.
Yeah. Now 3 is the index. Now your key is going to compare with ARR of 3 with key. Now after comparison, now the key is greater than of the 7 or less than of 7. Tell me.
Less than 7.
The yeah, less than 7 means we need to consider the left side list. Means the left side list is 0 to middle minus 1. This is the mid, right? M equal to now 0 to m minus 1. 0 to m minus 1 means that this is m minus 1. This is m plus 1 up to n minus 1. Means if you want to move, if the key is less than, then you take left list 0 to m minus 1. If the key is greater than, you take m plus 1, n minus 1. If the key is a middle, then match is done. Understand? This is the logic. Understand?
Yes, sir.
Yeah. Now key is now as per this key equal to 3. Now it is less than of middle means 7. Then we need to select left list, that is 0 to m minus 1. Now in this 0 to m minus 1 means again we need to find the middle. 0 plus m minus 1. What is m minus 1 value? 2 by 2. Tell me what is the middle value?
1.
1. Very good. Now this is the middle value. Now 1. Now compare 4 with 3. Key 3 with 4. Now less than or greater than?
Less than.
Now this is the middle. Now less than. Now 0 to m minus 1. Only one element. If you want to divide, there is no chance to divide. Then you need to compare with 3. Now tell me, is it equal to? Now this is the middle, right? Now is it equal to? Not equal to.
Not equal.
Not equal. There is no chance to division. Not equal. So that you can conclude the given element, key element is not found in the given list. Understand? Understand this procedure?
Yes,
Binary
sir.
search. Huh?
Yes, sir.
Hello? Yeah. Here this is only this is the logic. Here we are going to search sequentially using array. Here we are going to search after every time you need to find the middle with the division of two parts. After finding the middle element in that list, now you must compare with your key element. If it is less than, then move to the left list of that middle element. If it is less than, move to the right list of that element. If this process will be continue until unless the element is going to find or not. Are you clear? Are you clear?
Yes,
Yes,
sir.
sir.
Yeah. Now, but as per our syllabus, they mentioned here write a program that uses both recursive and non-recursive. Now, if I wanted to implement these linear and binary search, before that I want to know what is recursive, what is non-recursive. Tell me, what is the meaning of non-recursive? Quickly.
When a function calls itself, it's called as recursive.
Non-recursive means? Hello? Hello? Don't waste the time. Are you, is it audible? Whatever I'm asking, is it audible? Are you following my question? Are you following my question?
Yes, sir.
Yes, sir.
Yeah, tell me. Yeah, what is recursive? What is non-recursive? Okay, you people are done your C programming in your first year. Don't waste the time, please. I will finish it very easily because already you know these programs, but I am giving more clarity. You people have done these programs in your first year or not? Hello? 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 Unmute your mic and respond. Someone is texted. The process in which a function calls itself directly or indirectly is called recursion. Someone has to respond. That is right answer. Someone, no? Abhilash is given right answer in the chat box. Sir, I am expected to unmute and tell the answer. Don't waste the time here. Time is running. Now 10, 20, 10, 15. What is recursive? What is non-recursive? What is the meaning of recursive? What is the meaning of non-recursive? Hmm? Is this my voice is audible? My voice is audible. Hello?
Yes, sir.
Hello? Yeah.
Yes, sir.
Tell me what is recursive, what is non-recursive programming? What is the non-recursive programming? What is the recursive programming? That is what I am asking.
A method has the ability of calling itself to solve the problem. Recursion.
Yeah, right. The latter two students are responding. What about you? Okay. Anyway, good answer. A simple way here, non-recursive and recursive. So whatever the logic we are going to write, everything you have to write in one area in main only. Complete things, logic in a C program I am telling, so only within one block, only main block, you can write a complete logic. Here, whatever the linear search logic as well as non-linear search logic, in this only one main block is enough. Means no need to call any external function. Yeah, that is a non-recursive. The things will be happened and what the logic will be done in this only one method. Coming to the recursive, the logic you can write in one separate function, and from main we are going to call that function. So from where you want to call, you can call. Now after calling, it will be performing the task, then the results are going to revert me back. Like that, this function will be executing. For example, any for loop, if you want to write, that for loop will be run here only, itself only. But here what happened, it will be moves to this function call, results comes here, again work, again and again all these things will be done. Understand now? Means externally one function we are going to declare, that function will be executed itself continuously until unless find the result. If that result is get back to main method. This is the recursive mechanism. But non-recursive is everything you can write in the main method only. So this is what exactly recursive and a non-recursive program. Any program you can implement in recursive and non-recursive way. Clear? Now clearly understood non-recursive and recursive? All of you understood?
Yes, sir.
Yeah. Now, here in our syllabus, they mentioned recursive and non-recursive. Means you need to implement a linear search in a recursive and non-recursive fashion. And binary search also you need to implement in a recursive and non-recursive fashion. Clear? Means 4 programs we need to execute under 7th experiment. Understand? Linear search in a recursive and non-recursive, binary search also in a recursive, non-recursive fashion. In 4 programs, we are going to understand and execute under this 7th experiment. Are you clear now? Are you clear now?
Yes, sir.
Yeah. Now, once comes to the linear search, now this everything, whatever
sir.
we are going, whatever this operation we are performing in a linear fashion, in a non-recursive, you can write only one block of code main, and you can perform everything. If you want to implement it in a non-recursive fashion, you need to prepare one extra function and use main. From main, you can call to find this element is there or not. Means this for loop. Next. That will be done here, and that will be come back. The 2 programs. So this complete logic you can write in one main only. That is non-recursive. If you want to perform in a recursive, this searching operation, this logic continuously for loop, how we are searching k equal to array of I. That I will be incremented 1, 0, 1, 2, 3 up to n minus 1. That you write in a separate function. That function you call from main. This will be done recursively until unless the result is going to form. This is what exactly non-recursive and recursive of linear search operation. Clear? Clear? Hello?
Yes, sir.
Now same like that, your binary search also you can implement 2 ways. One is non-recursive and recursive. Here in a non-recursive, already
Yes,
I
sir.
told you that everything will write, means the reading the data and this mid and finding the mid and comparing mid with key and move to the left side list or right side list. Everything will be done in the only one area, that is one main, that is a non-recursive. But in a recursive, you take another separate function. In this function, you specify to find the mid and to take the decision to move to the left list or right list with help of this function. Here, so that this main method is going to call this function. You find the mid and take the decision, move to the left list or right list. That decision you again back to main, again it will be called here until unless it is going to find the data. Here this is what exactly here 2 ways we can implement any program, But specifically, they are given the seventh experiment, linear search binary search, in a linear and non-recursive and recursive fashion. So this is what exactly the implementation. Clear? Now clear how to implement the program, because the number of lines are very small and easily you can understand. I don't need to spend more time for program explanation because very simple program. So that this procedure, if you understand, then I will continue the program. Clear this linear search, binary search implementation in a recursive and non-recursive fashion. All of you clear this? Respond quickly.
Yes,
Hello?
Yes, sir.
Yeah.
Yes, sir.
Yeah. Now coming to programs. Sure, already I told you the program very simple. Here this is a linear search implementation in non-recursive fashion. It is very simple. We are going to read the array. The size is we have taken here 10. I have taken. This is the search element. Means key I want to find is a non-linear, non-recursive, so that I can write everything in my main block only. I don't need to specify any other function. This is what exactly. Later we are going to read the data with help of printf statement. Using scanf statement, we are going to read and place into the array. Okay, that is list. We are going to store the elements. Okay, using this size list, we are going to store the elements. Yes, my elements are ready like this. Uh, Linear, yeah. So like this, the array is ready. So after reading, so then enter the element to which element you want to search. Like this, you have to give key equal to 3. Then the key is ready. Now I want to search. Here, how to search? This logic, already told you, this logic also you write in a same main. Here, if it is a recursive, this logic you write into another function. That is what exactly. Otherwise, remaining things are same, because we need to search a linear fashion, so that we have to search 0 for 1 for 2 for like that. Once it will be get, then you will tell if the element is found in a particular location. Otherwise, the element is not found in the list. Understand this program lines? All of you understand this programming lines? Hello?
Yes, sir.
Very simple.
sir.
So out of our laboratory syllabus, these programs are seventh experiment is very easy. Shall I execute now? Shall I execute now? Respond, your time is running.
Yes, sir.
Yeah. Now tell me, now one, yeah, tell me the entire size of the list. Tell me the size of the list now. Any one of you? What is the size of the list you want to maintain? Hello. Someone unmute and respond.
Sir, 5.
5. You want to list 5. Okay. Tell me the element. 5 elements, integer values. 5 integer values. Any random order, because it is a linear. It is a linear search, right? Tell me.
Sir, 22,
22. Yes.
68,
68.
18,
18.
56,
56.
5.
5. Yeah. Now tell me the element. Which element you want to search? Which element you want to search?
56, sir.
63.
63.
53 you want to search. Now given element is not found in the list. Are you clear now?
Yes, sir.
Yeah, like that you can
Yes,
take
sir.
some samples and work out in your home. Okay? Clear? Clear this?
Yes, sir.
Yes, sir.
Same this linear list with recursive. Very simple. First of all, I am two blocks. Already I told you. This is for logic, how things will happen. This is for your main method. Okay? Just I will go with main method. So these all these parameters we need to define, you know very well, and you need to read the data from the end user. Yes, we are going to read, and you need to read the search element. Yes, we are reading search element, and now we are going to implement the logic. Here means the searching, linear search. That is what the function, here function called position equal to recursive ls is a function I have taken. Here array value 0 and n I am passing. So this function call will be done. Now we are going to find that element is there or not. Here means it is moving first indexing, second indexing, third indexing, fourth indexing. Like that indexing will be incremented. That will be return the position. So that position will be back to position. If position is not equal to 0, then if it is not equal to 0 means there is no element. There is element is found, not equal. Element is position equal to 0, element is not found. So that we are going to print. So the difference is we have to return one separate function for implementing of your task. Clear this? Very simple line. Yeah, these things already you people are aware. Even though actually it is not required to explain you, this is your task, but again I am giving. Enter the total elements in the array. Again I am taking 5. Now I am entering the elements, the random elements, you can take it. Yeah. Now I wanted to search 56. Yes, element found at position 4. 1, 0, 1, 2, 3. 0, 1, 2, 3, 50. Yes, 4. The element found at 4. Are you clear this? Clear this?
Yes, sir.
Yeah. Now, coming to the binary search with non-recursive. Already we know everything you must write in a main method. Already I told you very clearly. No need for separate function for your logic also. Now simply you are going to read the data and low and high and mid. These parameters are very important. Already I told you. Always you need to find the middle element. Based on the middle element only, we are going to perform your operation. So before that, you need the array, read the elements into the array. After that, you ask a user to provide the key. So based on that, low equals 0, high equal to minus 1. Nothing but you know very well. Low nothing but starting indexing, high is last indexing, minus 1. Very simple. While I is greater than or equal to low, then we need to compulsory always. When I is less than or equal to low or equal to low, then what happens? I is less than or low, then automatically there is no element to search. Then automatically you can tell that element is not found. That is what. Now you need to calculate middle element. Then you need to compare that key with the middle element. If it is true, then break. Otherwise, then again it will be performed. Then if it is else, then moves to the if key is greater than a of mid, then you need to take low is mid plus 1, nothing but right side list. Else the high is will take mid minus means left side list. Clear? Hello? Key is greater than a of mid. If the key is greater than means right side only. That's why you need to take low equal to mid plus 1. I always n minus 1 only. Here I have taken. Understand? Hello?
Yes, sir.
Now, if key is less than a of mid means left side list. If the left side list means we need highest. That I is low always here already I taken 0. So that I equal to mid minus 1. So this is what exactly. Understand? This will be run until I is less than or equal to low. This is the logic. Are you clear?
Yes, sir.
Here, if key equal to a of mid, anywhere if you are going to found, this is what, if key equal to a of mid, then break, means it will be comes here. If key equal to a of mid, then you can tell the key element is found at the particular location. Otherwise, the key is not found. This is a simple logic for the binary search, that is a non-recursive without writing any function. When you comes to the recursive, this logic you are going to write in the separate function. I will show you. Okay. Now understood this? Non-recursive understood everyone?
Yes, sir.
Then I'm going to execute this. Yes. But one thing, it is a binary search, right? The elements must be in a ascending order. Whatever the elements you are entering, those elements must be in the ascending order. Are you clear? Enter the size of the array. Now 5. Now enter the array elements in ascending order. Already I told you, you need to use one order. The random elements, it is not possible for binary search. Clear? Clear.
Yes.
Now I am going to enter the element. Yeah, now I entered 5 elements. All elements in the ascending order only. Your ascending order only works. Enter the key element. Here, which element you wanted to search? For example, I wanted to search 23. Now the key element is found at location 1. This is what exactly the program will run. Understand? Hello?
Yes, sir.
Yeah, now with recursive, already I told you this logic will you write under this function. Here one separate function I have taken here, that is a binary search function. In that binary search function only, in this binary search function only, I have taken whatever the logic here in same main method I have written, the same thing I have taken into one separate function I have implemented. Same, nothing is different. Same code, copy paste, nothing is there. Then from main method, we are going to read the data and we are going to call the element, that position. Once it will become, the element is found, otherwise the element is not found. Very simple code. Clear? Clear this?
Yes, sir.
Yeah. So that I am going to run the program, enter the element of the array 5. Now I am entering. Now I want to search one element 55. Now the element cannot find the element 55 in the array. So this is what exactly. Understood everyone? Non-recursive and recursive of linear and binary searches. Hello? Hello?
Yes.
Have you understood?
Yes, sir.
Yeah. Now this is what exactly your seventh experiment. But one more thing also I will tell you, that is for your task. I am giving some assignment to you, one task. Here in binary search, always the elements must be ascending order or descending order, correct? When you are entering.
Yes.
Hello?
Yes, sir.
Hello? Yeah, it won't accept random elements. If you are going to give random elements, you cannot get the binary search. Exactly. Correct? Respond, yeah, quickly.
Yes, sir.
Yeah. Now my option is, my assignment is just we are going to use any sorting technique. You know the sorting techniques. So many sorting techniques we discussed. One is bubble sort, the sixth experiment itself. Bubble sort, selection sort, insertion sort. Are you clear?
Yes, sir.
Yes, sir.
That sorting technique you can add here. You read the element. You are reading, right, elements. There no need to read ascending order or descending order. You take elements in a this you do it for experiment. After this, you do it for random elements. Then you read the random elements here. After reading this random element, you call that function. You can prepare one function for use bubble sort or insertion sort or selection sort. Any sort you can use it. And after using this, or maybe the merge sort, you know that. You use that sorting technique and sort the elements in ascending or descending. Maybe the ascending order. So that ascending order elements you give it to the binary search. Understand? This is your task. Means just you have to combine sixth and seventh experiments. And then you will get the binary search implementation. You no need to ask end user enter elements in a ascending order. You can ask directly enter elements. Then after after entering the elements may be sometimes not in a sorting order, a random order. And those elements you need to sort it using with your sorting techniques. So that you add in this program, then it will be good. Maybe you can feel it like a one sample project also. Are you clear what I am telling? Hello?
Yes, sir.
Yeah, please do it. Can you do this? Can you do this?
Yes, sir. We can do.
Yeah. Yeah, you do it. Here, these 4 experiments you complete and update your record. Along with this, you do this exercise and you show the things and the results. Some people now they are asking to join. I don't know why. For only for attendance, I think. Okay. Now everyone is understood. Now binary search and linear search for recursive and non-recursive.
Yes, sir.
Yeah, please execute these programs and